For our final example, we'll look at the power rule, which tells us that a to the m, entire power raised to the exponent n, is equal to a to the m times n. Well, let's see an example that illustrates this. Imagine we were asked to simplify a cubed to the 4. Well, a cubed is simply equal to a times a times a, so a cubed to the exponent 4 is like a times a times a to the exponent 4. Well, all that means is that we would write this out 4 times, and we would get a times 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 a, which would simply be a string of 12 a's listed out consecutively, which would simply be a to the 12th. Well, how can we apply this with the sorts of polynomials that you might see in questions? Let's take a look. Suppose we were asked to simplify this expression. Well, first we try to imagine the exponent on each component of the term. Now, what I'm about to show you only works when there's one term in the bracket. If this was 4m cubed plus n to the 4, what I'm about to show you wouldn't work. But we simply have one term here, 4m cubed n to the 4. So what we can do is think of this 4 as being 4 to the exponent 1, and then we can multiply that 2 times every exponent in the bracket, which gives us 4 squared, because 2 times 1 is 2, 2 times 3 is 6, 2 times 4 is 8, and now we get 4 squared, m to the 6, n to the 8. Now we can't simplify m to the 6 or n to the 8, but we can simplify 4 squared to 16, because 4 times 4 is 16, and we get 16 m to the 6, n to the 8. And we move on to our next question, which is simply xy quantity squared. Well, we think of this x as having a exponent of 1, and this y as an exponent 1. So 2 multiplies 1, and 2 multiplies 1, and we get x squared, y squared.